Hello, everyone. Welcome to our panel. My name is Argyris Kriezis. I'm a PhD student at Stanford University, and I'm going to be moderating today's panel, the role of cloud computing in Agile Satcom networks. I have an excellent panel with me. I'm going to just give a very quick intro of each one of them, from starting with Alan near me. So our first panelist is Alan Campbell. He's Principal Spatially Solution Architect at AWS. And then next to him we have Sergy Mummert. He's Senior Vice President of Cloud Sales and Partnerships at ACS. And then we have Sethu, Suvanam, CEO and founder of ReOrbit. And then just at the end, we have Peter Waskowic, Vice President of Satcom Products at Calian Advanced Technologies. So just to kick off this panel, I'm going to give about a few minutes to each one of our panelists to give a quick intro of where they work, their company, but also like how they got here. Alan, you can kick us off.
Thank you very much. So I'm Alan Campbell. I'm a Principal Solutions Architect in the Aerospace and Satellite Division at AWS. I'm focused on enabling customers with scalable, secure cloud solutions with a focus on Satcom, 5G, non-terrestrial networks, and AI and machine learning use cases.
You want to talk about your company at all?
Yeah, I'm with Amazon Web Services.
I'm with SGS. My name is Sergy Mummert. I lead the cloud sales and partnering activities, working with hyperscalers and their partners to either sell to them, through them, or with them. I've been in the satellite industry quite a while. I've been 23 years with SES, and that picture shows it. Anyway, I'll turn to Sethu.
Hello all, I'm Sethu, founder and CEO of ReOrbit. At ReOrbit, we build small geo telecom satellites. We are quite unique in the way we build our satellites. Today, if you look at all the manufacturers in the industry, they're largely building satellites as hardware, flying hardware components. We actually build our satellites like a flying software, pretty much like how Tesla is built, if I can use that analogy. Yeah? So we have now developed a very smart operating system as a backbone to our system architecture, and we treat hardware as a commodity. So whenever we get a customer, we look at the requirements, go to the market, procure all the hardware, glue this around our software. This one enables us to be quite flexible, but also this enables us to be moving data not just from space to ground, but also space to space, and I can expand on that as we talk.
Yeah, Peter?
Good afternoon, everybody. I'm Peter Waskowic. I'm the Vice President of Satcom Products at Calian Advanced Technologies. Calian Limited is a Canadian company. It's actually got a pretty broad range of capabilities, stretching all the way to healthcare, IT, cybersecurity. The part I'm most focused on, obviously, is the satellite communication side. We have a focus on ground systems. In my particular area, focuses on both hardware products and software products. So I'll bring some of that to the table today on the panel today so we can just discuss some of those topics. I've been with Calian actually in its predecessor called SED Systems for over 30 years. So I am as old as my picture and this viewpoint does look like, and been around the industry for a long time. It's really evolved a lot and is really changing a lot. So it's great to be able to participate today.
Perfect. So this panel is all about the synergy of cloud computing and satellite systems. And each one of our panelists approaches this in a different way based on their company. So let's start with you, Peter. If you can just talk about us, with your company, how do you view the synergy between cloud computing and satellite systems?
Yeah, so it's interesting because we're kind of at the intersection of the traditional analog side of the domain of Satcom communications. We build antennas, the actual big parabolic antennas, stretching down to smaller scale, more for LEO applications, as well as the software systems that ultimately get deployed in the cloud for network functions. So it's kind of interesting that we're able to see kind of the whole gamut. Once you get past the space side, we always call ourselves the essential link to the satellites up there in space from the ground. And so we transcend all the way from those cloud computing deliveries where you have general purpose compute in such great things as Amazon Web Services, all the way out to the actual antenna that's sending the signal up to the satellite, which is more where ReOrbit comes in.
Yeah, let's go up to the satellite. What do you have to say, Sethu?
Yeah, I mean, as I said, the industry is changing quite dynamically. I mean, if you go back 10 years ago, software-defined satellites have sort of evolved since the last 10 years. And at ReOrbit, we are taking it to the next step, right? For us, when we say our satellite is software-enabled, we see that the software for us stretches not just at the payload level, so it stretches from the platform all the way until the application layer. So we are trying to standardize the software layer or the backbone, software backbone, as I said, all the way from platform until the application layer, which then sits on top of a terrestrial network. So I think this is how the industry will evolve, where you will start seeing a seamless integration of your NTNs and TNs, and then the core there is how do you enable standardization of all the protocols on a standard backbone. And that's where I think exciting things are there for.
Great.
So this year's our 40-year anniversary for SES. So you can imagine we have to look at our customers and our partners and see how they've been adopting the cloud, how they've been transforming, even the new entrants. And so we've gone through the last 4 to 5 years, actually, we've been going through a digital transformation process where we partnered with the cloud providers to change how we do our business. And so we broke it down into 3 pieces. As an enterprise, in terms of the productivity and collaboration software and the skilling and culture of the company. As an operator, in terms of the systems we operate, moving much more to automation, orchestration systems, and virtualizing our platforms. And as a provider to our customers, working on solutions for our customers that adopt these technologies. And one example would be, we started providing dedicated private connections to the cloud. So if a customer came and said, I like AWS, we can provide them a direct connect via satellite. Then they would say, well, gee, how about some edge compute? Well, we could add edge compute next to our terminal, add the applications, and work with AWS in implementing it. So we've been moving through those pieces and transforming our business because it's very much becoming integrated, the cloud and Satcom.
Perfect. And what about you?
Yeah, I mean, I think if you look at all the different sectors of the Satcom network, if you start with like the network management system and the teleport and the satellite and the remote terminal, we're seeing cloud utilization across all of these sectors. So if you look at, for example, the network management system, it would most likely be in the region, sort of located in a main AWS region. But in the other 3 areas, satellite operators are looking at cloud edge capabilities. So looking at being able to deploy the same kind of workloads as they would deploy in the region, but now at the edge. And the big advantage that they see with that is it's essentially the same orchestration, the same APIs, the same deployment practices, the same security as they would have in the region. So it gives them this kind of unified single pane of glass in which to manage their overall network.
So for you, Alan, is it more about being able to provide cloud computing services to the satellite for their operations, or just being able to allow them to access your services at any point on Earth through a satellite network?
Yeah, I mean, I would say we are very focused on operator efficiency. So you can imagine if like a satellite operator has to trawl through a stack of manuals in order to sort of troubleshoot issues, that would be not the most efficient thing on Earth. So what we're trying to do is provide a lot of analytics, ML, generative AI capabilities so that operators can sort of debug packet loss, anomaly detection, signal-to-noise ratio changes, etc., with tooling rather than trawling through manuals.
Exactly. Let's go back to you, Peter. What about you? How do you view the services? Is it something you want to be able to provide to a customer, or something that you see the customers in orbit directly needing access to?
Yeah, so I mean, we're more focused on the ground system. So on the ground system, we're providing that software exactly like you were just describing, Alan, like network management systems that are deployed in the cloud. And they can be both sort of more towards the edge, right at the ground station itself. And oftentimes it's deployed there because it's making intelligent decisions right there at the edge, using AI or other sorts of algorithms. If an anomaly occurs, just switching things within the gateway right there and then. And then, of course, all that information, everybody needs more data nowadays, right? So feeding that information back to a centralized location where centralized decisions can be made. We also build things like resource management and capacity systems in order to optimize the usage of the resources on board the satellite in terms of the channels and the frequency allocations, all in real time, obviously, and it's dynamically changing every second.
And have you seen a lot of models that people have developed for terrestrial applications being used by your customers, through your systems?
There's starting to be that convergence with the terrestrial network. So part of our business also works over there. So we try to leverage some of those skills that we've learned over on the terrestrial side and cable television side in order to make sure that the access, at the end of the day, you're serving users, right? So you want to make sure that they're getting the best user experience. So to allocate the resources of the infrastructure accordingly to make it all work out best for the user is key. And those things are coming over from the telecom networks where they've had even much more practice than we have in the Satcom world.
Yeah, Alan, do you want to touch a little bit on this too? We are also on the ground segment. Like, have you seen a lot of use case of terrestrial models being actually used by satellite operators?
Yeah, I mean, we partner very closely with our own internal telecom business unit. And for example, just last week at a Mobile World Conference, they announced essentially an outpost capability for the Cloud RAN at the edge, at the CSP. And we're looking at very similar technologies for satellite communications, because as Peter mentioned, people want to be able to make decisions at the edge. They want lower latency. They want that predictability at the edge, at the teleport.
And do you have any examples of applications you can share with us about how they have been able to use that?
I mean, there's lots of really good examples I'm seeing of people using the cloud very effectively, both for sort of obviously the AI focus is very heavy right now. So a great example, I guess, Sethu is based in Finland, and we've got a partner in Finland, ISAI, for example. They do synthetic aperture imagery, satellite imagery, to basically retrieve images, but then the clever thing they do is they fuse that with ground measurements, social media, images, etc., using generative AI models on Amazon Bedrock, and it gives them a much more complete picture of kind of like flood damage assessment and first pass reports. So these are some of the kind of novel things that we're beginning to see now.
Sergy, do you have, I'll just ask after you, but do you have any examples either that you use through cloud computing models or any of your customers? Do you have any examples you can share with us?
I mean, I make a couple examples. One is I mentioned that the existing private network services that the hyperscalers provide, mentioned Direct Connect, we're now providing it via satellite. So we're taking that model now, making it available via satellite. We always want to make sure we can leverage the scale of the systems they provide. So they provide an edge compute capability. We want to see if we can just enable it with our communication service. The other example I would give is that SES, as part of its transformation and future systems, we're looking at an open digital architecture, right? So that we follow models and standards that can interface very well with other systems. As a multi-orbit operator, we build and own and operate our own systems, but we're also going to partner with other systems. And the interface with those systems, we need to use the standards. We use the architecture. So that's why we're trying to make sure we have a way to really integrate well with other systems so that we can provide that integrated service to our customers.
Exactly. I think, Sethu, you have a different perspective, Eldo, because you are the actual customer, but a lot of the other panelists have talked about, like, how do you use these models for your system specifically?
I mean, if you look at our end customers, are operators, right? And their customers are the typical decision makers, like governments, intelligence services. So for them, the key is about getting access to intelligence as soon as possible. So today, satellites are designed so that you generate a lot of data, and then that goes to the ground, and then those run on the different cloud services. So the way we are trying to design our system is that can we start even actually implementing the smart models on board the satellite, so that once you start generating, you take your first picture, can we already start creating intelligence on board the satellite, and then you could leverage the amazing ground and the other services, so that you could actually reduce the reaction time to an end user. So we are actually now, just to elaborate on that, so we are actually launching a satellite late this year. Within an European ESA program, where we'll be demonstrating an optical Intersat link. So it's a LEO satellite with a multispectral payload and an optical comms, where once we take a picture, we try to process the whole data on board the satellite. So we run a lot of complex algorithms on board the satellite, and then the data directly goes to the end user. So by this way, you could start basically reducing the reaction time. One other thing what Sergy mentioned was the multi-orbit. And we are seeing that systems are getting much more multi-orbit. And also one trend I think we'll start seeing is, until today, satellites have been put in a box of this is an SAR platform, this is a multi-sensor platform, it's a comms platform. I think in next 5 years, I think those will be erased, because once you have a system that's connected to each other, and then the data are freely flowing. So you don't have to see satellite as a carrier of one sensor, but satellite becomes a carrier of multiple sensors, because effectively your system is connected to another system. So when we design our satellites, and when I go back, I said we are designing our satellite on a standard software backbone. So we actually basically don't see the data coming in as an image or telecoms or whatever. We just see data is coming in, data is going out, and how fast can we move this data through satellite.
Perfect. And what about you, Peter? Do you have any on the state of AI models? Do you have any experience on that from your customers?
Yeah, I think AI is really just beginning to take off in our industry. I mean, some people might disagree, but I will try to insert the letters A and I as every second character in my statement here. But anyways, it is quite interesting. There's so much application for AI, and everything's getting really, really a lot stronger. A couple examples that we're using with, we've been doing some work with the Canadian Space Agency, both on tasking some of their observation satellites to make sure that they're being utilized the most efficiently, and using AI, being designed with AI in mind in order to really, really tune those models, as well as looking at anomalies on board those spacecraft, and through the telemetry systems, able to utilize AI in order to better predict failures ahead of time. So it's all quite some interesting work in the AI world.
Yeah, I think just circling back to the ground segment, what makes it all possible, and going back to you, Alan, traditional Satcom has a very fixed architecture. The chain of each company might even be completely custom, can even be used from other companies. Where do you see the industry going towards virtualizing the ground station to be able to enable all these great computing services?
Yeah, great point. I mean, Sergy sort of touched on the value of standards. We've certainly seen that in telecom for many years, and the addition of NTN and 3GPP in the last couple of years has really enabled mobile network operators to work much more closely with Satcom providers. So the same's needed for Satcom, right? And so over the last year, there's been a new consortium that's developed called WAVE, the Waveform Architecture for Virtualized Ecosystems. And basically what it's intended to do is this kind of next-gen, transformative, agile network for the ground network. So what is WAVE? Well, it's built on top of Diffie. And basically what it's trying to enable is the Satcom baseband functions, the modulation and coding in software-defined radios, right? And so you would be able to run these either in the cloud at the region level, or if you're looking for kind of higher latency, sort of lower latency, higher bandwidth type use cases, then you would typically do that at the edge with something like AWS Outposts.
Perfect. What about you, Peter? Have you seen any change in the ground segment?
Yeah, just to add there, I mean, we're part of the Diffie consortium as well, and one of the early members. We also come from that traditional world where there was custom-built hardware for all those different pieces within the ground station chain, which worked fine. But it's really interesting now as this digitalization transformation is occurring. It really opens up a lot more use cases and applications. Again, we're just kind of on the edge of that. People are really interested in it and are starting to think about deployments in places like SES, but it really can be transformational. What I always think of it allows all these network virtual functions that you can take that Diffie stream, throw it to various processors along a chain, and we're just starting there. But you can just imagine the different transformations you could use for different use cases in order, whether you need something better for spectrum monitoring, whether you need to even do some interference cancellation in a different network function. There's so many possibilities that are there. I liken it, the phrase I use is, in the future we'll have an app store for all these different network virtualization functions.
Yeah, that's a great analogy. And we touched a little how we're transforming the ground segment to enable. And just want to go to our satellite operators here. It's kind of for a LEO or a MEO satellite to be able to access and tap these computing services, you require this like constant, regular communication with the ground. Like, how do both your systems, starting with Sergy, allow that to happen? Being able to connect satellites.
Okay, so there's a couple things, and I'll pick a little bit on Sethu mentioned, which is, we mentioned our multi-orbit architecture. We mentioned that we've done a program for NASA to demonstrate how both GEO and MEO can support the LEO systems, right, with the space data relay connection. So for the GEO side of it, the C-band, we provide actually a persistent global link to the LEO. So they can actually task and update their systems and not wait for a complete orbit to get updated. So that way they're always connected. They can actually update their systems and get imagery quickly. The second architecture is the MEO, MEO, providing a relay backhaul. So to your point about an image being captured, they want it quickly, they want it on site, they want to make sure chain of custody is maintained. That is something that we can do with a backhaul. So again, that's an RF-based approach, but it provides that persistent link to the systems. I just want to give one more thing. We talk about ground. The other part we have to think about is when we do multi-orbit is the customer premise, right? You show up with 3 different modems for 3 different systems that are 3 different orbits.
Correct.
They're like, what are you doing? You're building a gateway at my premise, right? So that has to also get more, the standards and virtualization of those systems will really help us condense that. We did a demonstration at Mobile World Congress last week where we showed the 3 orbits operating. We had Starlink, RMEO, and GEO operating under a complete demo, and we had an orchestration service provided by Quivia, a new company, that it studies the application characteristics and prioritization and maps that application across the networks that are available to it. And it uses AI, to your point, about learning and optimizing the traffic flow.
Perfect. So it's more of like a virtual, in a way, user terminal where it can work with all the different modulation schemes, all the different satellite systems, regardless of what they use. But are there any standards on that end, or is it more like at this point?
We're trying to leverage the standards that exist in the marketplace so they interoperate, but there's more work to be done.
Sethu, what's your perspective?
To start with, at least from our end, we are trying to create a standard on the space segment, right? That's what we are trying to do with this architecture that we are creating. But also today, I mean, you have seen this transformation happen around 2006, 2005. If you go back, again, taking from the Finnish example, you had the grand old Nokia phone, which was just used for calling and text messaging. Now you take your iPhones. Basically what iPhones did is they bought their cameras, the music devices, everything into one. So by going purely software, the boundaries between different applications have been erased, and that has led to new applications such as Uber and so on and so forth. So that's what I think basically we are talking here, right? We are basically at a stage where we are at a tipping point that space as an industry has been largely seen from the eyes of hardware, and people are more and more trying to look this from the perspective of software-driven architectures. And it's a matter of time when I think a similar evolution as computers and cell phones have gone through 20 years ago, space industry will go through. So.
And we have talked about all these great things you can do with data, but let's touch a little on like the data security aspect of it. Like, Peter, if you want to take a start, how do you, what system do you use to ensure that all this data collected and distributed to all these systems are stay safe?
Yeah, I mean, security is all encompassing, right? So it starts at the hardware level. You need to make sure you have physical security, goes all the way through the chain, through the network, ultimately to, of course, a data storage location out there in the cloud or on premise, wherever it might happen to be. And it all needs to be secured to these standards, not just for military applications, also for commercial applications. Security is absolute paramount. And we're really seeing a shift. For a long time, we used to deliver systems that, to organizations that would manage their own IT infrastructure. And that's difficult to secure at all because the security is changing every day, essentially, as new threats come up. It has to continually keep evolving. So it's critical and really helpful, actually, once you get to more of a cloud storage service provider like Amazon or Microsoft, if I can mention them now without trouble. But anyways, because they really have figured out all of these security standards. If you've ever bothered to look at any of the NIST standards, it's a stack of documents from the floor up to here, and trying to comply to all those things is extremely difficult on your own. So having helpful partners that have breathe security day in, day out, and allow others like ourselves just to develop the applications that record the data that then gets stored properly, or it makes it a lot easier.
So Alan, how does AWS manage that? You have a lot of customers. Like, how do you ensure each customer gets the data security levels they require?
Yeah, I mean, security is basically job one at AWS, and one of the things we're seeing more of is under the kind of whole data protection umbrella is data lineage, right? So if you think about all these new models, generative AI in particular, right? If you ask a question, you want to make sure that the response that comes back is from a trusted source, right? And so this is kind of this new thing that all of our customers are beginning to come to us with. So we have a couple of solutions for that. One is this thing called fine-tuning. So you basically bring your own sort of labeled data, so you train it with your own sort of Satcom specific data so that the answers you get back are much more reliable. And then another technique is this thing called retrieval augmented generation. So you load up a knowledge base of your specific sort of docs and articles, etc. So the answer is only going to come back from that particular knowledge base. So the net result with that is you get a much better, more reliable answer, and it solves this kind of data lineage conundrum.
Perfect. And Sergy, your company has communication satellites. You have multiple customers where you are serving them all through the same satellite. You're passing all their data. How do you ensure the data of all these customers stay separate and protected?
Yeah, so oftentimes it comes down to the type of customer and what level of security they're looking for in their system. So a commercial customer, oftentimes we provide them a link and they use their own encryption or security architecture, and we are actually not involved. For government customers, we offer different versions. We have our managed services for government customers, but we also have what we call our sovereign service. And what that basically means is they can pick their own platform or waveform, run across our transparent system, and effectively they have a physical private network running across our system. We don't see their chain, so they feel totally comfortable. Where they landed is their domain. So we do have different levels. We just have to architect it appropriately and give them that flexibility.
Yeah. And Sethu, I think your company approaches that a little differently. You're more in the micro geo business, kind of function of having a satellite exclusively for a specific customer. How do you view that security aspect?
So firstly, your data is as secured as the weakest point in the link. And most often, the weakest link is the satellite in the whole scheme of things, right? Or most of the times. So that's, maybe I'll give you a side story. So early on when we started developing our architecture, we got in a cybersecurity consultant who was not from the space industry. So after he went through all the architectures, the first thing he said was, it's very easy to hack an average satellite than an iPhone. So that's how the architectures are today on a general basis, right? That is mainly because satellites today are largely built as a hardware-based entity, so I'll not repeat myself there. So how do we approach that? One, we design, so for us, cybersecurity is a part of our design, given that we are largely focused on software, so we take it very seriously. And two, what we have also done is that, as I said, we are now building the standard backbone, which means we have an API that's specifically dedicated to the encryption models. So we give two options. So one, if you are selling to a sovereign nation, then most of the times these nations do have their own services or encryption layers where they could straight away put those layers on top, or we could build it ourselves in-house. Security is definitely a key aspect when it comes to spacecrafts, and today, unfortunately, a lot of satellites are not as secured as a lot of the networks that are on the ground. And I think it's more a mindset change that requires from the spacecraft industry or the satellite industry to see how we can actually design satellites much more secure.
Mm-hmm. Perfect. And then I think we're just going to move a little more towards like the future trends of the industry now, and I'm going to say the magic word, LLMs. So what do you think like kind of like is the future? Like are we going to see like LLM-like models running in space? And I can start with like Alan on that.
Sure, yeah. I mean, we're kind of just getting started with this whole large language model paradigm, but you're right. That's probably where it'll end up, is this, I guess, small language models. So how do we get there? You obviously can't put an enormous large language model on a spacecraft. So there's a technique called model distillation, and essentially all that is taking a large language model and distilling it into a much smaller domain-specific model that can be run on an edge platform. So that's basically model distillation to enable an SLM in space. So then with that, you can imagine an operator might be able to do some of their like TT&C with natural language commands, right, which will be very powerful. And we're beginning to see some applications of this. Last week at Mobile World Conference, our telecom team had distilled a model into a much smaller x86-based device. So these things are definitely up and coming.
All right, and Sid, do you have anything to comment? Kind of like, especially when you're talking about software-defined satellite, do you envision having models actually running on the satellite to be able to?
I think, I mean, in-orbit distributed computing, I think that's where the world is going. I mean, you already, I think, as Sergy sort of mentioned that when you have multiple orbits and data is moving. But also today, I mean, certain satellites are fully utilized, their capacity, certain satellites are underutilized. So once you start connecting systems and once you have standard, let's say, protocol or architectures that are running between multiple satellites, you could start basically running a lot of models on both these satellites. So you could start generating intelligence way before it even comes down to the ground networks. And that is bound to happen in the next couple of years. And two, I see, again, given whatever is happening in the world, I think space has come up front, and we are seeing that as a satellite manufacturer, that data sovereignty is becoming quite important for a lot of nations. And I think there'll be a lot of new changes coming in, the way countries handle their data, the way the data moves, and also the way the whole warfare evolves, right? So today the warfare is evolving on basis of data. So that'll be a way new dynamics that will happen all the way from space going to the ground on purely on satellite and space industry.
Mm-hmm. And do you see an advantage to actually being able to have this computing power in orbit versus just being able to have a constant communication link with the ground and just leveraging ground resources? Do you see an advantage to being able to actually do it in orbit?
I mean, it will be, at least the way I see it, I mean, I would like to hear from others, at least the way I see it is it's not either or, it's actually a chain. So the more computing power you have, the better, better and faster intelligence you get. So today the problem is it's not starting from the source, it's actually starting once it comes back to the Earth. So once you have the ability to actually start the data processing or able to compute in orbit where the data is generated, so you could get down the reaction time or time to act. So it'll be all an integrated system from the space to the end user. Potentially, maybe in 5 years, people could start actually specifically selecting a particular satellite and saying, I want data from the satellite, and the data processes and comes to your cell phone. So the whole data chain is connected from the space to the end user in their palm. That's how I see it.
Yeah. And do you have anything to add?
Yeah, I was going to add, that's a good point, because I kind of sort of see it as self-healing networks in the future. If you have these models that know the weather patterns, they have understanding of the interference environment, they understand the capability of the spectrum and the power levels, these things could predictably adapt, and so you can have a network that's much more adaptive to your point, and that's where the technology really helps. So not even the user making a conscious decision, their network's just up. Their uptime is there. They get the SLA they want.
Alan, do you have anything to add to that?
Yeah, I mean, if you're going to send data down from a satellite, make sure it's useful, right? So make sure you've got compute on orbit that can make that decision, right? So I mean, we did a partnership a while back with ReOrbit and Unibap, and simple cases depending on the sensor that's up there. So let's say there's obscuring by cloud cover. Don't send down these images that are all obscured, right? So make a decision up on the satellite to only send down the useful data.
And we even see some use cases for deep space applications. If you can imagine doing the processing out there and having less data to send back all the way from distant planets, you really save yourself a lot of that data transmission time and bandwidth.
Yeah, that's one touch too. It's kind of like once we go into also looking into the lunar economy, it's kind of like there might be more of a need to actually process that before reaching all the way back to Earth for these applications. So in a little bit, I'm going to open it up to audience questions to start thinking what do you want to ask. And just want to go back, starting with Peter and coming back to me. From your perspective, what's like the biggest misconception about cloud computing and their role in the space industry?
I'm not sure if this is a misconception. What I will say is cloud computing seems easy, but I think for those of us who are trying to implement it, there's some work to be done there. So we're transitioning from a lot of these, I'll call them legacy or traditional systems that were deployed at very specific locations without the benefit of the cloud computing. And it's a transition point where those are now starting to move. It's not a one-day action to do it, so it's going to take a little bit of time. And so I'd say maybe that's a misconception I can state.
Would you be brave enough to give us like what your thoughts are? Like
we're super brave. We're super brave.
Like kind of like a time frame for this?
A lot of stuff we're finding is people are doing on-premises cloud or private cloud. Mm-hmm. No offense intended to the public cloud, of course, but just for economical reasons as well as proximity reasons, various things. But utilizing the cloud architectures, but not necessarily going everywhere in the public cloud. That goes as well to some of those things you were saying about data sovereignty and needing data to be in certain locations. Anyways, there's lots of challenges to solve. I think as a whole, the industry's up to it, I really think it'll probably happen within the next 5 years, primarily because the security is so paramount, and the only way to really achieve it is those hardened cloud platforms and able to do it.
Perfect. Sethu?
I'll take it in general from the satellite industry. Today, again, I wouldn't call it a misconception, but today there's a lot of focus on vertical integration. And the idea there is you vertically integrate, you have big control of everything that you do. I think that is already the myth is being burst now. And the way I see is there'll be a lot of horizontal integration happening. I think you mentioned, Alan, the partnership between Unibap and ReOrbit and you. So there'll be a lot of synergetic companies coming together, building solutions together, which is what I meant by horizontal integration. So, and that's what will also rapidly evolve the industry as such to going towards what we've been discussing here.
I call it an evolving conception or appreciation of applying hyperscale to space. We're so used to scarcity, expensive space systems, moving to a more abundant, affordable, easy to adopt, access, and implement, really applying that hyperscale model to the space services. And to me, that's super exciting. I think we're just scratching the surface. So I think our conception of what's really possible is evolving very quickly.
Yeah, I think just sort of defeating the misconception that the cloud is just like a big region, right? We talked earlier about how cloud is going across the edge, right? The teleport, the space edge, etc. Just continuing to get that message out and making sure that customers see the value of using cloud in all areas of their network is important.
Perfect. If you want to start lining up for questions, I'm going to give some time, and then I also have some questions after you all start giving your thoughts. I don't see a lot of people. I have a few one. If people want to still think, I can go through a few more things. Okay. I only have to wait 6 seconds until people start. Oh, so there's the microphone up there. If you can state your name and also what company or where you're from, and then your question. Yeah.
So Alan Snyder, I'm kind of an expert with AWS stuff. And my question is, there's this idea of a lift and shift where people with legacy infrastructures and business have sort of moved into the cloud. Is there a lift and shift equivalent for space, for satellites?
Right, so this is when I opened with this kind of single pane of glass concept, that's kind of where we're going. So let's say you've built, let's take the waveform example we started with, right? So I think most of our customers are not going to deploy a new waveform at an AWS outpost on day one. Right? What they will do is they will test it on a variety of different instance types in the cloud, refine it, see where they're getting the best performance, and then they'll use a dedicated outpost for lower latency, higher bandwidth at the teleport. But it's the same model, right? It's the same. You mentioned like lift and shift. They'll essentially take that same practice and just move it across to the outpost and then say, right, I want to deploy that same stack to the outpost instead of the region. Good question.
And as long as there are no other conversations, just going to continue the conversation. And if people have questions, just line up. I'll see you and I'll go and call people. So, okay, let's tackle a few of the other questions we have here. So, what do you think is the biggest challenges for the adoption right now? Is it more like a technological or waiting for some technology like the virtualized ground station we're going to be that will allow us to really adopt this, or is it more like an economical? Like, do we have the systems in place? Are the companies willing to invest? I'm not sure if we want to start from the bottom end. Yeah.
I think it's a combination of things. You know, like I mentioned a little bit earlier, nothing gets developed in a day. So, you know, a lot of the technologies are there, but the implementations are still coming. The designs, the ideas are there. You know, for example, going back to the waveform, you know, still, you know, depending on what kind of bandwidths you're using, what kind of data rates you need. You know, general compute server isn't necessarily enough. You might need something with an accelerator card, you know, like is provided in some of the cloud architecture. But those sorts of things, you know, the technology is ramping up still, and it's catching up for those particular applications like a modulator or a receiver. And you know, there are definitely challenges with economics. You know, changing the models. You know, it might cost more money, you have to close a business case, and people are working towards that to make it all a reality.
So, firstly, okay, we cannot defy the laws of physics. So, within the boundaries of laws of physics, I think the key thing is the mindset change. Today, I mean, space industry has been quite traditional, and specifically Satcom industry has been very traditional up until probably 5 years ago, 4 years ago. And as an example, I mean, in the last 3 years, we personally have been seeing a shift in the big operators from the way they are thinking. You go back to big operators 4 years ago and say, do you want to buy a satellite from a new space player? The answer would be no. Today, a lot of new, you know, big operators are actually asking for, can't you guys take more risk and give us more innovative solutions? So that's a good mindset change. But and that should be driven with adequate financial support as well. So because at the end of the day, innovation comes at a cost, and then that should be, you know, driven. And from where I come from, Europe, that's a big challenge. European investors are very conservative. They are pessimistically optimist. So on that, there is this huge step up when you're sort of comparing, let's say, the companies, and I'm a startup now, purely looking from the startup perspective. There's a huge step up when you're comparing a startup in US as compared to Europe in terms of driving innovation because of the restrictions in terms of how fast you could actually get access to money. Things are changing in the right direction, but that's a big challenge.
Would you say they're waiting more for some of these things to be proven out, maybe in the US that's a little more like risk tolerant, before following up in Europe, or you know, are they willing to step up and take the risk?
As an example,
yeah.
If you want to raise 10 million euros in Europe, it's going to take 8 to 10 months. That's a given, right? It's an average timeline. That's a given. I think you could do that in a couple of months in US. So one, probably it's the mindset. Maybe, you know, in US. People can take big bets as compared to Europe. Also, Europe is largely data-driven. To convince an investor, you need to show a lot of data. So it's largely data-driven approach that they take.
So what about you, like kind of like obstacles to adoption, economical versus technological?
I agree with it's a mindset cultural thing. Even within SCS, we had to go through a process to sort of force through the organization a change, and not just sort of taking existing processes and things and just putting from on-prem to, it's changing the whole way we think about our business. And so, and in many ways, we've had to do it more than once. We'll try something, it didn't work, we'll try something else. But you got to do it faster and faster. So I think part of it's cultural mindset. The other thing is the market is really driving us and our behavior, and seeing the adoption of our customers. We have, we provide both data communication and media services. So the media services company have been adopting cloud for quite some time, and they'll tell you we've been doing it for 6-7 years, and we're still in the middle of our journey. We're still getting the experience out of this. So, so also that's sort of another thing is it's even if you get into it and you start doing it, you're going to learn and keep evolving, and it's not something you say, oh, it's almost over. I think the deeper you get, the more you go. So the adoption part of it is some of the customers want the traditional service that we provide. They want us to give them the commodity megahertz and don't get involved. And I think that's moving over to in time to people saying, I want more of a solution integrated service, and I don't want to get into all the implementation. So these adoption barriers have to come down. Yeah.
What about you, Alan? You work with a lot of customers directly for their applications too, like.
Yeah, in terms of like barriers to adoption?
Barriers to adoption, is it mostly like they're waiting for some technology, for example, the virtualized ground station to do that, right. Or is it more like also like investment? Can they invest in that capability and are they willing to do that?
Yeah, I mean, so one of the barriers we do see, so obviously we work with a lot of government customers, so we have our standard AWS regions and also our GovCloud regions, and for obvious reasons, FedRAMP, ITAR compliance, etc., some of the services just take longer to get to GovCloud than they would a standard AWS region. So we get customer sort of frustration about the latest services not yet being there on GovCloud. But that's been a big focus actually recently. So a lot of the services, for example, Amazon Bedrock sort of foundational models are now coming to GovCloud basically because the customers are demanding it.
Mm-hmm. So you have something like...
So one of our biggest customer base is nation satellites, just to emphasize on what Alan was saying. So what we are also seeing is there is a dynamic evolution in the way the nations are also thinking, right? And that's actually, in parallel, there's a dynamic evolution of how the geopolitical situation globally is also evolving, which means that one of the biggest restrictions today as a platform provider or a solution provider is how can you satisfy the needs of a nation? Say, for instance, nation A doesn't want to have a solution coming from nation B, but probably core components of your systems are coming from nation B. So in that sense, that's also quite an interesting challenge for companies like us where you are in a world where you're horizontally integrated, so you're leveraging solutions from different entities situated in different countries. So it'll be interesting to see how that challenge will be tackled.
Mm-hmm. And before I start the next round of questions, give me one more opportunity for everyone to ask a question. Going once, twice. Okay, I guess the audience have any questions. Okay, we'll continue. Now I want to talk a little more about like the user experience we're talking about. And based on the things you have, like your interactions with all the customers, are you seeing people are looking at the cloud resource and like, you have this task I've been doing this manual way or this more analog way, and now I can use cloud computing to optimize that? Or do you see the customers thinking like, okay, like I have all this computing power, what new can I build? Like, do you see a lot of these like new applications versus just like, okay, I'm going to use the cloud to optimize my tasking, optimize my analysis? Start with you, Alan.
Yeah, I mean, I think way back, maybe half an hour ago, Peter mentioned things like interference detection. So we're now doing that in the cloud. So my next session that I have to run to after this one, we're going to show that basically two different ways to do interference detection in the cloud. And the first one is the traditional machine learning approach, which is still fine. So basically sort of clustering and then classification to be able to say this is this type of interference or this type of phase noise or amplifier noise, etc. And then the second methodology is using generative AI, so using some kind of multimodal, so image to text type model that is able to say, right, this looks like phase noise, this looks like IQ gain imbalance, etc. So in the past, where maybe you needed sort of spectrum analyzers, etc., now there's the opportunity to use cloud computing capabilities to do things like interference detection. So it's kind of a whole new way of looking at the same problem.
I really like how we're in a world where the standard method is machine learning. And we're talking about the next
Legacy.
Yes. Quite good. What do you say?
I'll mention a partner of ours. We have an offshore partner who, that manages offshore platforms, and what they've been doing is improving the private wireless network on these offshore platforms, increasing the coverage throughout the system. All this metal and stuff causes a lot of interference and gaps, right? So they've done a great job on the platform. That enables a bunch of new applications. So they have the whole video on the person when they want to go look at what's going on if there's a problem. They have all the different sensors ongoing, and they want to manage this remotely, right? So they have the actual data plane of all this information coming back to them, processed in the cloud, but they also have a control plane where they're managing all the sensors, they're working with the people, and those are in 2 different clouds. So putting that, oh, I'm sorry. They're all one, no. Anyway, so the point being, though, is that they need the network to be adaptive enough so they can actually move that kind of capacity. So when they started talking to us about our MEO service was, all this data is coming back. We need it to go to the appropriate cloud. Can you actually create separate networks to do so? And the answer is yes. But just to give you a sense that the more these networks are enabling more applications, they've got edge compute to look at these all these sensors, all this data, and they determine which goes over the network, which stays in terms of, you mentioned this on orbit as well. So just gives you an example that it's moving very fast, and they're improving the performance and the optimization of these platforms because they're pumping tremendous resource, and they want to make sure it's always on. So
in addition to 3 different levels of cloud, if you will allow me this term,
yes.
of like at the edge, exactly the location, at the satellite, or even all the way back, and having different data flow at different places.
that's true.
Sethu, what are your thoughts?
The question, what does the customer need?
Yeah. It's more like, no, my question was primarily like, does the customer design to change their existing functions and see how they can optimize them further using cloud compute, or do they just go and get the new applications now that they have this capability, kind of rethink the application completely?
Firstly, to start with, our primary customer base is nation satellites. So we are primarily going after sovereign satellite capacity. So within that boundary condition, so what today we are seeing is largely customer wants to have data sovereignty and to own the whole data by themselves. So in that sense, yes, because they want to own the whole data, it means that they are putting a lot of requirements on us that is way forward looking. As an example, if a nation wants 3 gigabits per second, that's their total usage capacity today. They're demanding 30 gigabits per second, as an example. So then it's a back and forth where we say, okay, you probably can take the middle ground. So because it's at the end of the day, it's an optimization between cost versus how much they could afford and what they could keep. That's one. And 2 also is the ability for them to run the data by themselves. And a lot of these nations today don't have the capability by themselves to operate the satellites, because traditionally they've been going to bigger operators, leasing the capacity, and just getting the data. So one of the key challenges in an interesting way is how can we catch their hand so that we just don't give them the black box, which is the satellite, but then enable them to operate the satellite, have the TT&C with them, and establish the whole data value chain in their country, and then let them be a bit more independent when it comes to controlling the whole data value chain. So that's how we are seeing the demands from our customers.
Just a couple points from me, I guess. The first one is actually, all the stuff that happens around our industry has really kind of forced us to up our game. So, we're talking about user experiences. It's so easy nowadays to just type something into a browser and get a well-formulated answer on things. And traditionally, our systems would have been built more engineer to engineer, very obscure in the way they interact, with the system and how you get an answer. So it's interesting that we can start utilizing some of these techniques to almost make it so it's a very easy conversation with the system to extract the data you want. So we're starting to leverage those types of tools that are easily used with software once you have the data. And the second thing in there is just that this ability to record so much more data using cloud resources allows you to store the data and without really knowing all the ways you're going to use it in the future. And so then you can take that data, and even though you had the initial use application, maybe it was an image or something, that you're getting from an Earth observation satellite, you can then start to build some applications on it to then take that raw data and transform it in ways that allow you to get to whole new applications. So it's a really interesting use of cloud resources in order to make things for the future with data of today.
No, I really like what you said, kind of like the synergy of being able to use like data that, like combine different sources that were not traditionally used. And I'm curious if the rest of the panel has any similar examples too of like how, maybe Alan, like how, like you had different applications and then like suddenly with all these tools you realize you can actually combine them. You mentioned some of the applications about the imaging app, the SAR satellites, combining like the data from the satellite with like data of the internet and all this type of stuff. Like, can you elaborate more on that?
Yeah, I mean, the ISA example I mentioned earlier, and then certainly you're going to see that a lot with 5G NTN, right? This kind of fusion of Satcom and non-terrestrial networks. So when you have these kind of more agile capabilities, it's much easier to do that.
Mm-hmm. I have a question, I see.
I did. It's fascinating talking about all the positive things that can happen, but I'm imagining along the way you've discovered a few things that didn't work out. I wondered if you could kind of talk about lessons learned, maybe something where you had unintended consequences, where the optimization kind of went the wrong way or something like that. Just kind of curious what...
Anybody wants to... Yep.
Start? Okay. So I think one of the things was everybody embraced cloud as long as it happened in someone else's department. Yeah, this is a great idea. They can do it. That's great. Don't bother my thing. So the company had to do a thing where if you wanted to order a server for your activity, you had to go to the CTO to get approval to really justify it. We really had to force a cultural change because you can kind of get comfortable, if you will. So that was one part of it. I think when you adopt new technologies, there's the traditional way of sort of doing it, testing it, flying it on an experimental. Well, time is going very fast to do all that. So we're looking now at doing it differently in terms of implementing new technologies in our systems. But they will break. I mean, I was raised in the culture of, failure is not an option, and now it's fail fast. So that change really had to go through the organization. And I think maybe watching our customers, they're telling us their war stories as well, and asking us to sort of, go on that journey with them and learn together. So willing to take some risks together with your customer is an important thing because a shared learning is better than just keeping it to yourself.
I echo fully on that. Maybe one thing I'll also say is like being quite flexible as an solution. When we started out, we never started out as an sovereign satellite provider. We were purely a satellite manufacturer. But things evolved over a period of time, and then we saw a nice little market that started growing and growing and growing. So having solutions that could actually enable you to pivot a bit towards different markets without pivoting largely on the direction you're going. So that was an interesting learning, and then I completely echo with you the mindset change. I think our experience has been, when we started out, we've been very vocal about satellites should not be built as flying hardware. You have to think satellites in a different way. A lot of them did not listen, but when things change very fast, and overnight people come to you saying, yes, this is right. So you just have to be there.
Yeah, and with 2 minutes to spare, I just want to ask a quick one-sentence answer to all of you. I think, what's the thing you're most excited about in the satellite industry? And if you can just formulate it in a sentence, you can start with Peter.
Okay, one sentence, right?
You can do one word if you prefer.
I'll go with rate of change. I've been in the industry a long time, and we proceeded along at a slow, steady, incremental pace in a very good way. But now the rate of change is just astronomical, and it's awesome.
Continuing from that, erasing boundaries. As I said, until today, satellites are always perceived in a certain boxes. And going forward, I think those boundaries will be removed, and we'll start seeing more holistic networks.
Yeah, I'm going to say innovation. I mean, there's so much going on. The barriers coming down across. We grew up in an industry where MSS should not talk to FSS, should not talk to, right? And all those things are coming down, right? So to me, oh, that wasn't on one word, was it, though? Oh.
It's all good. So, I mean, I would say I get excited by sort of major step functions in the industry. So if I sort of take my crystal ball, it'd be great to see a few years out a sort of secure marketplace of waveforms for the teleport, where operators like SES could go and build much more agile Satcom missions with this marketplace of secure waveforms.
Perfect. Well, thank you all for our panel today. And audience, you can catch the speakers after off the panel if you have any other questions.
Thank you.
Thank you.